Now with the radian measure, there are certain applications that can be derived basically because the definition is tied to the length of arc, right? Remember we said 1 radian is when you walk the radius amount of distance on the circle. So we can do the following. We can say that theta, this angle, is the ratio of how much you travel on the circle divided by the radius. So if theta is s over r, we can say s is r times theta, where theta is in radians. For example, given that a circle has a radius of 15 feet, find the length of the arc with the central angle pi over 3. Then s equals r theta, which is 15 times pi over 3, which is 5 pi feet, which is approximately, again use the pi button on the calculator to get this value. This should be 15 feet, approximately 15.5 something. It's okay if you leave it at this place. Again, important that this is in radians and not degrees. So if you use degrees, then that's going to be a incorrect answer. Given that a circle has an arc length, so there's a circle and this length is 4.6 centimeters and the central angle is 120 degrees, find the radius. Now the first thing is to change this to radian. So we can use our formula. To change that to radian, you have 120 times pi over 180. So it's 2/3 of pi. Now you have, in this case, you know s and you know theta and you're finding r. So this is 4.6 r times 2 pi over 3. And again, we can use our old method of cross multiplication. This gives me 3 times 4.6, which is 13.8, equals 2 pi r. So r is 13.8 over 2 pi, which comes out to 21.68. What's the unit here? Centimeters. So that's the radius. As another application is the area of the sector of a circle. Now, if I walk from here to here, if I take this region, how much area is covered here? It's given by 1/2 theta r squared, where again theta is in radian. And the last example is that of a angular velocity. If an object is moving in a circle, it has two kinds of velocity, linear and angular. The linear velocity is how fast it is moving along the circle, and the angular velocity is with respect to the arc length. So all you have to know is that the relationship between the linear and the angular velocity is that this is linear and this is angular, is that it's v equals omega times r. Okay, example, the area of the sector of a circle with radius 2.50 centimeter. So you know this area is 3.28 meters squared. You have to find theta. The area is 1/2 r squared theta. Right? If you go up here, that's our formula for the sector area. Sorry. It's right here, 1/2 theta r squared. So in this case, we know this is 3.28. This is 1/2, 2.50 squared theta. So theta is 2 times 3.28 over 2.50 squared, which comes out to 2 times 3.28 divided by 2.5 divided by 2.5. 1.05, and again important that you put radians because it's not in degrees. An object is moving in a circular path, so you have something that's moving. Radius is 10 centimeters. Angular velocity is 3.80 radian per second. We know V is omega r, so it's 3.80 times the 10 centimeter, which is 38 centimeters per second. A radian is dimensionless, so this just directly becomes the velocity of the object. So really simple applications, which all arise from the natural definition of radian measure. That's it for this week.